moving on, let's look at right triangle trigonometry. So a triangle in which one angle is a right angle, 90 degrees, a right chair, is called a right triangle. The sides opposite the right angle, so opposite, is known as the hypotenuse, and the remaining two sides are called the legs. The Pythagorean theorem, which we've seen already, can solve for any one of the legs or the hypotenuse with a squared plus b squared equals c squared. So if we place our angle here in standard position, meaning 0, 0 on the unit circle, then the coordinates a, b, okay, right here is a point on the terminal side of this angle theta that is on our circle x squared plus y squared equals c squared. All right, so that's all we've done is said that if we put this now on an actual circle, then we can do the same thing with the Pythagorean theorem to find a particular side. So as we've known, our sine y over r, cosine x over r, and so on. But what we call these now is by looking at our right triangle is if we're at y, okay, and all of this is dependent on this angle. So if we're at a point right here and our y, then our y value would be the opposite, and then our r, the radius, hypotenuse, so opposite over hypotenuse. Cosine being the x value would be the adjacent, and then once again the hypotenuse. And then of course the tangent being the sine over the cosine, the hypotenuses cancel, and so you get opposite over adjacent, and then so on. These flip on the other side with our very well-known identities, which brings us to this very, very cool song. So sit back and gel. Do they say gel anymore? This song is lit, man.
Yeah, you know what it is. SOHCAHTOA, 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 SOHCAHTOA. Yeah, you know what it is. SOHCAHTOA, 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 SOHCAHTOA. Yeah, you know what it is. When I'm doing math, I do it big. Yeah, screaming that's nothing. When I'm doing math, that's stunting. When you see me in the class doing math, I'm using SOHCAHTOA, 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 SOHCAHTOA. Put it down from the whiteboard to my notebook. SOHCAHTOA, 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 SOHCAHTOA. Learn the trig ratios or you're gonna lose. Sine is opposite over hypotenuse. Why you look confused? Which one you gonna choose? Cosine's adjacent over hypotenuse. We're not done yet. Don't get complacent. Tangent is opposite over adjacent.
All right, we're back. That was interesting, huh? Okay. So moving right along, if I want to find exact values of the 6 trigonometric functions of a particular angle, then I will do so with my SOHCAHTOA, SOHCAHTOA. So looking here, if I just label all of these, so I'm going to call my hypotenuse C. I'll call the one leg A, and then B, I don't know what that is, so I gotta find it. So once again, this is hypotenuse. In this case, this is my adjacent, and what I'm looking for is my opposite. So I can do so by c squared equals a squared plus b squared. C squared, 5 squared equals 3 squared plus b squared. So I'm going to end up with 25 minus 9, because I did the 3 squared, chunked it to the other side. I get 16. So then of course b equals 4, because these are going to be positive looking in quadrant 1. All right, so away I go with my SOHCAHTOA. So sine opposite, so let's write our opposite up here that we just found. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is sine over cosine. And then secant, I flip the sine, I fooled you. I wrote it up there just to mess with you. I flip the cosine. So cosecant is where I'm going to flip the sine. And then finally cotangent is where I'm going to flip the tangent. Easy enough, right? Okay, well, let's continue on. So two acute, it is so sweet, that's so cute. Two acute angles, they're less than 90 degrees, are called complementary because they complement each other if their sum is a right angle. So in other words, if you have two acute angles and they add up to become a right angle, then we call these complementary. So, with right triangles, the two acute angles are complementary because the right triangle or triangles add up to 180. I already have one angle's 90, so the other two have to add to 90. So looking at this with complementary angles, what's kind of nice is that if I want to find the sine of B, opposite over hypotenuse, B over C, well, if you notice the cosine of A, okay, so is adjacent over hypotenuse would be the same thing. So that's all of this is saying is that you can use these to complement the other. If you know one, then you can easily find the other. And so given all of our angles, and this relationship is known as cofunctions of complementary angles. So in other words, if I know the sine of 30 degrees, then the complementary angle, looking up here, would be the cosine, and then whatever it adds up to get to 90, which would be 60, and so on. So tangent, cotangent, secant, and cosecant. That these are all cofunctions, and kind of nice to be able to solve for one if you know the other. All right, so solving a right triangle. Let's get me my pencil here. So it says if B equals 2 and A is 40 degrees, find A, C, and B. Now you don't have to, but I kind of like to draw these out. Good job. And at least I got a right angle. And that way I can label everything. So the capital letters are always your angles. So we'll call this one A, which is the 40 degrees. And this one will be B. And then the opposite of your angles match your letters. So in other words, this would be A, this would be little b, and then of course that's a little c. Doesn't look like a little c, but it is. And then my angle C. So from here, I know that A is 40, and I know that C is 90. Well, B has to be whatever would cause that to be 180 degrees, right? Because we said triangles have to add to 180 degrees, so that's 180 equals 130. I put minus B plus B plus, and so certainly B would have to be 50. So check, that's solved. All right, now what I could do is, and you typically like to use the angle that's given because possibly we could have made a mistake here. I mean, I almost subtracted some stuff, right? And so I'm gonna look at this angle, the 40 degrees, and I know by looking at this angle, I know little b, which I didn't put it here, is 2, because that's given. So if I took the formula, the tangent of 40 degrees, which is opposite A over adjacent 2, that would allow me to solve for A. So it sounds like a pretty good deal, right? And again, you might say, well, why didn't you use the sine or the cosine? Well, if I use one of those, then I don't know what C is, the hypotenuse. And in this case, if I'm looking at this angle, okay, I can see with this angle, all I don't know is the opposite A. So I can solve for A. meaning I would take 2 times tangent of 40 degrees, and then I would plug that in a calculator and I would get something like 1.68. Okay? And then because I know adjacent, then it probably would make sense to find the cosine, because the adjacent 2 over c, and then I could solve for c. So c equals 2 over cosine of 40 degrees, and that's approximately 2.61. So we did it. We done did it. We solved it. Good job. And we'll be back.
When I'm doing math, I do it big. Yeah, screaming that's nothing. When I'm doing math, that's stunting. When you see me in the class doing math, I'm using SOHCAHTOA, 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 SOHCAHTOA. I put it down from the whiteboard to my notebook. SOHCAHTOA, 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 SOHCAHTOA. Yeah, I'm using SOHCAHTOA, attacking these problems like Rocky Balboa. Geometry till I DIE. Shoutouts to my boy Pi in the 314, my boy E up in the 271, my boy Derivative, my boy Square Root. You know I got you, baby. Math Road Records.